What's up, you freaking geniuses? So in this video, I'm going to teach you how to multiply together complex conjugates, right? So here we have a complex number, right? 9 plus 2i. So this is in standard form, and the standard form of a complex number is just a plus or minus b times I, where a and b are just numbers, and I is your imaginary number, okay? And I is defined as the square root of -1. Okay, now in order to multiply a complex number by its conjugate, all you have to do is put this in parentheses, and then we're going to multiply it by the same complex number, so 9 and 2i. The only difference is we're going to change the sign right here in the middle. So here you can see we're adding, so here we are going to subtract, okay? So basically, we have two binomials, right? 9 plus 2i and 9 minus 2i. So we're just going to multiply these two together. So we can do that using the FOIL method. So first, let's say 9 times 9, that's equal to 81. And then we have 9 times -2i, so that's equal to -18i. And then here we have 2i times 9, so that's positive 18i. And then lastly, 2i times -2i is -4i squared. Okay, now let's combine some like terms. So here you can see we have -18i and positive 18i, so they'll just cancel each other out. So all we're left with is 81 minus 4i squared. Okay, now let's simplify I. So again, we said I is equal to the square root of -1, right? So let's just write it over here, the square root of -1. But as you can see, we're squaring it, right? So we're squaring this. Now, whenever you square a square root, or square a radical, those simply cancel out, and you're just left with whatever was inside the radical. So in this case, that would be -1. Okay? So here, I squared is simply equal to -1, right? So let's plug in a -1 right here for I squared. So we're going to get 81 minus 4 times -1, all right? So we get 81, and then -4 times -1 is +4. So then this is simply equal to 85. All right, so that's our final answer. All right, here's the next problem we're going to do. So now we have -1 minus the square root of 5 times I, all right? So again, in order to multiply this by its complex conjugate, we're just going to put this in parentheses, and then we're going to put parentheses here, and we're going to put the same complex number over here, right? So we have a -1 and a square root of 5 times I. And then again, all we do is change the sign in the middle. So here we're subtracting, so here we're going to add. Okay, great. So now, again, let's multiply these together. So first of all, -1 times -1 is +1, and then -1 times positive root 5i is equal to negative root 5i. And then in the middle, we have negative root 5i times -1, which is equal to positive root 5i. And then lastly, negative root 5i times positive root 5i. Well, first of all, root 5 times root 5 is equal to simply 5. Okay? And then we have a negative times a positive, which is equal to a negative, right? So we have -5. And then we also have I and I, so I times I is equal to I squared. Okay, great. So now let's combine like terms. So again, normally the two terms in the middle you'll be able to cancel out. So we have negative root 5i and positive root 5i. So those cancel out, and we're left with just 1 minus 5i squared. Okay, so here we're going to get 1 minus 5 times I squared. So I squared again is just equal to -1. So here this is equal to 1, let's see, -5 times -1 is +5. So this is equal to 6, all right? That's our final answer. All right, now for this last problem, we have just the square root of -20. So this looks kind of weird, right? Because first of all the other problems were in the form a plus or minus b times I. But as you can see here, we're taking the square root of a negative number, which we can't do. So that means if we simplify this, we're going to get an imaginary solution, okay? So we can convert this to basically this part of the standard form, but we're missing this part, right? So we don't have some regular number out here. So if you want, you could write this as 0 plus the square root of negative 20, okay? Now if we simplify this a little bit, we'll get 0 plus, and then here again, like we said, we can convert this into an imaginary solution. So let's do that over here to the side a little bit. So the square root of negative 20. So the first thing we can do here is basically factor out that negative symbol. So negative 20, let's break that up into 20 times negative 1, okay? So now that we factored out that negative 1, let's break each of these into their own radicals. So here we can break this up into the square root of 20 times the square root of negative 1, okay? And remember, I is equal to the square root of negative 1, right? So then this is simply equal to the square root of 20i, all right? So that's where our complex number, or our imaginary number, comes from, right? That's where bi comes from. So let's plug that in for this square root of negative 20. Let's plug in the square root of 20i. So now we have it in standard form, so now let's multiply it by the complex conjugate. So here we're going to put parentheses around this guy, and then we'll put parentheses here. And so here we're going to say 0 minus the square root of 20i. Okay, now before multiplying these two together, let's simplify what we have in these parentheses. So 0 plus the square root of 20i is equal to simply the square root of 20i, right? And then it's going to be the same thing over here, right? 0 minus the square root of 20i is equal to minus square root of 20i, all right? Now we can multiply these together a little more easily. So the square root of 20 times the square root of 20 is equal to just 20, right? Similar to the last problem where we said the square root of 5 times the square root of 5 is equal to just 5. Okay, and the reason that works is, well, the square root of 5 times the square root of 5 is the same thing as the square root of 5 squared, right? And when you square a radical, those cancel out and you're left with whatever's inside the radical, which is equal to just 5, right? So that's why, again, square root of 20 times the square root of 20 is equal to just 20, all right? But here, this is positive and this is negative, so positive times a negative is a negative, so this is equal to negative 20, all right? And then lastly, we have these i's times, or this I times this I, which is I squared, all right? Now here, this is going to be equal to negative 20 times I squared, and like we saw, I squared is equal to just negative 1, right? So we'll plug in a negative 1 right there for I squared. And then here you can see that this is equal to simply positive 20. Boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.